Okay, today we're going to look at a couple of problems from section 2.7, our related rates section. Okay, so here's a problem which says a baseball diamond is square with sides 90 feet. So let's draw that diagram. So here we are with our baseball diamond. That's a square. And each side is 90 feet. And then it says the batter hits a ball. Here's home plate. Here's first. Here's second. Here's third. And he runs at a speed, or she maybe, runs at a speed of 24 feet per second. At what rate is the distance to the second base decreasing when the batter is halfway to first? Okay, so here goes the batter. He's running down, or she's running down there, halfway. So that's 45 feet from each base. Here is that distance to second base. I'll call that, let's call it Z. And so we want to find the rate at which that is changing. So they don't give us a equation or relationship, but we can see that what we formed here is a right triangle. And I'll call that side Y and that side X. So our equation would be X squared plus Y squared equals Z squared. And all three of these, or at least two of these, we'll talk about one side, are changing with respect to time. But our equation is not written as a function of time, so we have to do implicit differentiation. So each one of these are going to be taken, we can take the derivative rather of each one of these with respect to time. So we have 2x, then times dx dt, plus 2y dy dt is equal to 2z dz dt. Now, one of the things I see is that this distance here is not changing, the distance from first to second. So that tells me that dy dt is going to be 0. So since that's 0, that term is eliminated. I'm going to divide both sides by 2. And we have x dx dt equals z dz dt. And the dz dt, that's the variable that we are solving for. So I need a value for x, dx dt, and z. They tell us we're halfway to first, so that x is 45. They tell us the batter is running at a speed of 24 feet per second, so that's our dx dt. And then now z, so we do have to use our Pythagorean theorem, so z squared equals 90 squared plus 45 squared. Z would be the square root of 1,000, or rather 10,125. And so we have, the square root of 10,125 times dz dt, dividing by that. So there's our dz dt. Rounding this to 3 decimal places, because that's our standard, we would end up with 10.733, and our units are feet per second. So again, we have a Pythagorean theorem relationship, and we took the derivative of each section with respect to time. So hope that helps, and we'll see you soon.